G'day folks, MBS here. Today I'm going to be checking out a couple of oxygen sensors, a 1-wire and a 2-wire sensor. We're going to be doing it in a vise off the vehicle. If you haven't got the means of checking them on the vehicle, which is far easier of course, if you've got a little scheme tool like this, you can plug it into an OBD2 port and you'll end up with a pattern like I'm going to show you in a minute, how the oxygen sensor looks like on a screen. Obviously, if you've got a car in the 86 era up to about 96, you won't have an OBD2 connector to check it that way, so you're going to have to do it manually. And I'm going to show you how to do that. Now, there are a couple of different sensors around. There's a zirconia, titania, and a planar. We're not going to cover the titania. We're going to do the zirconia and the planar, which is the same. They just look different to each other, but they are both voltage generating sensors. So that's why we've got the voltmeter out, ready to go to check the sensor that's in the vise right now. And I've also got another cool little device I've had for quite a few years that I'm going to put here and connect it up also, just to see the voltage changing. Now, if you've got a multimeter, you really want one with a bar graph. Yeah, this one hasn't got one, so it's going to be hard to follow the voltage going up and going down. You'll see it changing, but you won't see an actual reading specific. That's why I've got the lights here, so you can actually see the voltage. This goes from 0 to 1 volt, so this is going to vary up and down from probably about 0.1 to 0.9 volts as we heat the element up and deprive it of oxygen so that we get a voltage reading. Now, when we deprive the sensor of oxygen, the voltage will go up to about 0.9. When we take the flame away, the voltage will go down, and you'll see that all happen on that gauge on the left, much more visual than looking at a bar graph or a voltmeter. But if you do have a bar graph multimeter, that'll work for you very well. It'll give you sort of a similar look to the LED lights on this one. Okay, 1 wire in the vise right now. We've got the red lead from the multimeter going to that lead, and we've earthed it out through the vise. Alright, so we should get a voltage on that once we get this all warmed up. You're going to need a butane torch so you can heat this up. Now, when you're heating this up, we don't want to burn the guts out of it. You just want to heat it up enough to make it start working, and you'll see what I'm doing in a minute when we fire this up. So let me get this all happening, and we'll bring the camera in a bit closer and have a better look at it. Okay, we're all set to go. We'll get some heat into this now, and we'll see what happens to these two gauges. Now, while it's warming up, I'm getting a bit of warmth in it. You know, this is a maintenance device, which basically means you need to replace it every so often. Now, on a 1-wire, 2-wire setup, you probably want to replace this every 50k. On a 3 and a 4 wire, probably every 80k. And a planar, you can go 160k without having to worry about replacing it. And here we go, we're starting to produce a voltage. Now, if we could keep it at 0.45, which is right in the middle there, that would be stoichiometric ratio, lambda 1. And that's what the car is looking for your computer. Now, you'll notice that when I bring the torch over it, the voltage goes up. I take the torch away, voltage goes down. So this thing constantly goes up and down, up and down, up and down, just like it is there on the left-hand one. Okay, so this one's working fine, and that's basically how you test them. Okay, so pretty simple. Now just remember that when you're hooking up the voltmeter, you hook up the red lead to the feed lead going into the sensor, being only 1 wire, and make sure you've got a good earth so you can actually get some sort of response out of that. Now we'll stick the 2-wire in there. We'll show you how we hook that one up, and we'll test that one. Rightio, we've got the 2-wire all set up, and we'll start applying some heat to it. And already we're starting to get very minute voltage out of the voltmeter. Oh, should start, here we go. Oh yeah, there you go. Flame comes across, voltage goes up, voltage goes down, voltage goes up and down. As you bring the flame across, you deprive it of oxygen and the voltage goes up. Now, obviously you can't follow it too well on my multimeter because it's not quick enough. But you see on the left one, that's exactly what it should do and respond fairly quickly like that as well. If you're doing a U sensor, you obviously might not get it as good as that one. So what you're looking for is the delay it takes for that sensor to read any voltage. Now, connecting this up was a little different to the other one. It's a 2-pin, so you hook up the red voltmeter to one pin and the black lead of the voltmeter to the other pin. You don't earth the body of the sensor. Now, when you're doing a 4-wire sensor, 2 wires will be white, just like this one. So if you get 2 white wires, that'll be your heater element, and then you'll have the other 2 wires. If it's a zirconia type filter, that'll be your generator voltage on one of those wires, and the other wire will be your earth. So if you've got a wiring diagram, that'll help you out to work out which one to put the voltmeter on. I think all that'll happen is you'll just get a negative reading if you switch the 2 wires incorrectly on the 2 wires you're supposed to get your voltage from. So it's no big deal. And yeah, and that's how you test a 4-wire one. Now, if it's a titanium one, it's not a voltage generator. It's the resistance changes in a titanium sensor. So you'd actually switch this over to resistance and check the what's happening on the leads. As you put heat on, the resistance will go up and down. So yeah, so that's the only difference of testing the two between a titania and a zirconia. Now, if you want to know more about oxygen sensors, I've got a pretty good article on my website that goes into quite detail how these things work. But one thing you have to be aware of is these things can become contaminated fairly easily. They can get oil fouled, which destroys them. And if you don't use the right silicons, as in inlet manifold gaskets, exhaust gaskets, that sort of stuff, if you're using silicon compounds, you'll destroy these also. I've done a lot of these replacements and then found out that when my new oxygen sensor failed about 3 or 4 days later, we had to investigate why, and I found the tappet covers were glued down with normal silicon. Yeah, so that was a customer learned a lesson there because they did the tappet cover themselves. So yeah, you've heard sensor safe. Yeah, you would have seen that in a lot of products when you go to buy silicons and all that sort of stuff. It would say sensor safe. Even some oils are required to be sensor safe because all that ends up in the exhaust system somehow through the combustion cycle, and it'll contaminate your oxygen sensor over time. These things are pretty essential if you want good fuel economy, yeah? Alright. Now, this is the way I just showed you to test the older vehicles when you don't have an OBD2 connector. This will be the only way you could probably test it. But if you've got a scan tool, yeah, that is the best way to test the oxygen sensor. Alright, on vehicle. Keep it on board, and if it doesn't do the waveform like it's supposed to, throw it out and put a new one in. Remember, these things need replacing on a regular basis. They don't last forever. They will become contaminated over time, and they need to be replaced. Otherwise your fuel economy on a late model engine will just sort of dive because the sensor isn't reading correctly. Sorry, and your computer will just richen the mixture up to compensate if it's getting a sensor that's reading lean. So yeah, basically that's it, guys. Hope you enjoyed that, helped you out. Catch you in another video.